Okay, so we're recording. So everybody, welcome back and good morning. Let's see. So today's Thursday. So last lecture for the week. So just a reminder, we don't meet tomorrow. So you can sleep in if that's your prerogative. And then, well, let me cast and we'll share the rest of the reminders here. Okay, sweet. Hopefully my Teams doesn't crash like last time. Okay, great. So there's a few reminders that I want to put out there. First of all, the last drop day, I should say the last drop day without a W. Is going to be, I think, 1/19, 2021. That's Tuesday. Okay, so if you want to withdraw from the course and not have it show up on your transcript that you were ever even in the course, then you need to do that by Tuesday. So who would want to do that? I don't know. You might want to do that if you got into the course and you realize, oh crap, this stuff is like way above my level or something like that, and you think you need to go down into like 111 or something. Or if you're just like feel like you want to put off taking math until the next semester or something like that, that's when you want to do it by. You can drop without a WF, which is like withdrew while failing, up until March 27th, I think. So about halfway through the semester, or a little bit later, you can still withdraw and just have a W and not necessarily a WF. So by then you'll have had one or maybe two exams. So you should have a pretty good idea of like the direction which your grade is headed by then. So that's the last drop day. My math lab is now activated. I sent an email with instructions on how to get signed up for the My Math Lab. You can find it on the announcements section of Blackboard. Pretty much any class information that you need will be somewhere on the Blackboard, if not just on the syllabus itself. But just a reminder, our code is Homery, my last name, 86171. Okay, so you'll go to the My Math Lab website, you'll click on sign up, you'll create an account, and you'll input this code in order to register for our class. And I believe that the cheapest option is going to be something like $69.99. And that'll get you like an 18-week access to the ebook and the homework, which will be just long enough for us to do the semester. There's a more expensive option which allows you to, I think, retain access to the ebook indefinitely, but I'm not sure that that is necessary for any reason. If you want to hang on to it, then fine, pay the extra money, but I think probably most students are going to choose that option because it's the cheapest that I could find. Please do let me know if you find something cheaper than that so that I can share it with the rest of the class. So that's my math lab. Okay, exit slips. Don't forget, after each lecture, we have exit slips. And they're due 1 week following every lecture. Emphasis on every lecture. Okay, so it's not 1 per week, it's 4 per week. And what you do is you watch the video or you attend class and then you take the exit slip, and ideally while it's still fresh in your mind what we did in class, because it asks you questions about what we did in class that day. So that's exit slips, and those are just graded on completion. So all you have to do is take them. You can just, it takes like 5 minutes maybe, and you can just like type out your responses to those questions, and then as long as your answers correspond with the proper lecture, then you get full points for that. So that's exit slips. Homework. I'm gonna post a homework. Tomorrow. And the way our homeworks will work is that it will be due in 1 week. Where should we find the exit slips? If you go to Blackboard, you just click on course content and then exit slips. So let me put that here. You go to Blackboard, course content, exit slips. That's where you find them. The homework will be due exactly 1 week from tomorrow. So it'll be due on January 22 of 2021 at 11:59 p.m. So the way our homeworks will work is at the end of a week, I will post a homework covering the material that we covered that week previous, and it will be due 1 week hence. Okay, so this homework that is due on 1/22/21 is covering the material from the previous week being this week. And that's how it'll be pretty much every week. And I will most likely post a homework every week unless there's a weird exam scheduling thing where we don't really have anything to work on. Okay, so that's homework. And lastly, don't forget we have a 3-day weekend this weekend, so no class tomorrow because we don't have class on Fridays, and no class on Mondays or on this coming Monday because it's Martin Luther King Day. Okay, so get to sleep in 4 days in a row. Nice. All right, any questions about any of these reminders about the exit slips, homework, drop day? Yeah. Okay, well, if you think of something, most of the information, if not all of it, should be on Blackboard. But if you can't find something there, then go ahead and email me and I'll get you set up. Okay, so back to math. Let's review what we were talking about last time. So at the end of last lecture, we started talking about rational expressions. Remember, rational expressions are expressions which are a ratio of polynomials. Okay, so our numerator and our denominator are going to be polynomials. And we discussed how to simplify rational expressions. And what that amounted to was essentially factoring the numerator and factoring the denominator and trying to cancel out any terms which are present in both the numerator and the denominator. Okay. It's not unlike simplifying fractions when we did that back in grade school. Okay, there was one thing that I did want to talk about, which was pulling out a GCF. Let's see, where did I talk about that? It was further up. Let me just talk about it here. When we factor something like x to the 4th minus 3x cubed, okay, when we factor something like this, what we want to really do for something like this, since we can't hope to actually, use our typical factoring techniques, since this isn't a difference of squares, is we just want to first go about our factoring process by pulling out a greatest common factor. That's always the first step in any factoring that we will ever do. Okay, so we want to pull out a GCF. And what do I mean by a GCF? I mean the largest common, well, I guess the greatest common factor. That's a pretty descriptive name, greatest common factor. I want to find the thing that is the most complicated expression which I can divide out of both terms of this thing. Okay, so in our case, it's x cubed, because x cubed goes into 3x cubed, and x cubed can be divided out of x to the fourth. But we couldn't choose, for example, x to the fourth because we only have 3 powers of x on the second term. So in our case, it's x cubed. So the way we would factor this is by taking out our x cubed, and then we've got x minus 3. Okay, and that's considered fully factored. Okay, so the factoring process is first do the GCF game, if applicable. Secondly, you do usual factoring or grouping, or however you want to do it, if applicable. Okay, so that's how we factor. So maybe I'll give one more example. Let's try x cubed minus 2x squared plus x. Okay, so if we want to factor this, we should first look for a greatest common factor. In our case, we are going to have a greatest common factor. What's the GCF that I can pull out of this expression? Somebody help me. Yeah, we can take out an x, right? So first we can write this as x times x squared minus 2x plus 1. And now I should factor, okay? I should do usual factoring, okay? I can do grouping if I want. I can find something that satisfies the grouping and play around with that, but I think I can just see it here. I think this is going to be, and you want something that multiplies to positive 1 and sums to negative 2. That's going to be x minus 1 and x minus 1. Okay, so this was the first step of GCF. And then this was the second step of actually factoring. Okay, awesome. We got participation coming out of our ears. I love it. Okay, so that is what I wanted to say about factoring. So going back to rational expressions, when we want to simplify rational expressions, all we want to do is use this factoring process on both the top and the bottom and cancel out anything that we can cancel out. So that's going to be the main game for simplifying rational expressions. So we practiced simplifying a couple here. And then we briefly started talking about multiplying and dividing rational expressions, okay? So I'll run everybody through this again really quickly. What we do when we multiply, so considering the multiplication that we're asked to do in this green box here, okay, so we have two rational expressions and we want to multiply them. We multiply not unlike how we would multiply fractions, right? If we do 2/3 times 5/6, well, we just multiply straight across. We'd multiply 2 times 5 and get 10, 3 times 6 and get 18, and that would be our answer, right? So we're going to multiply in the same way here, except we have to be a little bit careful because we have to treat these as if they're in parentheses, okay? Treat them as if they're in parentheses because we want to multiply all of x squared plus 7 times all of x minus 4, okay? So we just multiply straight across, and then if you want, you can FOIL things out as necessary, but really most of the time, we probably would rather have an answer like this, because when it's nice and factored like that, we can kind of see that we have it in the simplest possible form. Okay, so I would say it's not totally necessary to carry this all the way out to this last one there. Okay, and when we divide rational expressions, we do the same thing as what we used to do when we would divide fractions, right? If we want to do 2/3 divided by 5/6, what do? We just multiply by the reciprocal instead. I don't like dividing, I like multiplying, and if I can just write this as 2 over 3 times 6 over 5, that's much easier. I know what to do now, I just multiply straight across. So I'd get 12 over 15 in this case. With rational expressions, we play the same game. Instead of dividing by this rational expression, we're going to multiply by its reciprocal, and we just explained how to multiply rational expressions. Okay, so that was what we talked about right at the end of class. So let's do some practice. Okay, let's see here. Maybe I can, I'm going to rewrite this first one here. Okay, so what we want to do now is basically just multiply straight across, right? So we've got two rational expressions here, so we're just going to take the numerator and multiply it by the numerator, take the denominator and multiply it by the denominator. Heidi says, sorry I'm late asking this, is he sharing his screen? I am sharing my screen. Can everyone see my screen? Yes, okay. Can't see it, but I think it's something on my end. Okay, yeah, you might try rejoining the call. Sometimes that that will do it, or sometimes restarting Teams. Yeah, I much prefer the user experience in the app as well, over the web client. Okay, well, hopefully we can get that figured out. If you can't get it figured out, you can always watch the recording after. Okay, so we want to just multiply these straight across. Now, at this point, you have a little bit of a choice. You can either multiply straight across and then factor, or you can factor and then multiply straight across. I personally, and this is a personal decision, like factoring each expression before multiplying. But that's a personal decision. But we're going to do it my way because that's how I want to do it. So we're going to factor each of these first, and then we're going to multiply straight across. So first of all, we're going to rewrite the entire thing as a multiplication of two rational expressions. And the first one, let's see if we can factor the numerator. X squared plus 3x plus 2. I want two numbers which multiply to 2 and sum to positive 3. I think that's going to be x plus 2 and x plus 1. And now what we're going to do is simplify the denominator, or rather factor the denominator. It looks like the only thing we can do is take out a GCF of x. We'll have x times x squared plus 3. Now, if we want to factor the right-hand side, we should take out a GCF on top. We'll have, in fact, we can take out 2x, and we'll have x squared plus 3 left over. And now we're going to factor the denominator on the right-hand side. That's going to factor as an x plus 2 and x minus 1. Is there anybody who'd like me to go into a little bit more detail about how I factored either of these two quadratic expressions? Okay, those are two pretty simple ones, so hopefully we can get those figured out. But if you are still struggling with those, don't panic. Just come see me during office hours or set up an appointment. Okay, so what do we want to do now? We just want to multiply straight across. So essentially, this amounts to just getting rid of the multiplication sign in the middle. We're going to do x plus 2 times x plus 1. We're going to multiply that times 2x, and we're going to multiply that times x squared plus 3. And now we're going to divide, and we'll do x times x squared plus 3 times x plus 2 times x minus 1. And now the simplification game begins. We just want to cancel out anything we can cancel out. We've got an x squared plus 3 on the top and the bottom. We've got an x plus 2 on the top and the bottom. We can't cancel x plus 1 and x minus 1. Those are different terms. But we can simplify these two terms with the 2x and the x. We're going to get rid of the x and we'll be left with just the 2 on top. So all in all, what we're left with on top is going to be 2. Let me switch back to purple. We'll have 2 times x plus 1. And then in the denominator, the only thing we have left is x minus 1. All right. And that is how we kind of take that process all the way. Okay, any questions about how we simplify these rational expressions or how we multiply rational expressions? Can I explain why I canceled out the 2x and the x? Absolutely. So, okay, so I only canceled out the x here. Let me say that. So we still have this this 2 existing in our simplified expression. So I didn't mean to cross out the entire 2x, so that's one thing. But second of all, we had a rule when we learned about exponents. We said that if we have x to the a and we divide that by x to the power b, we had a rule for what this would become. We said it would become x to the power a minus b. Okay, that was the rule that we came up with. So for example, if we have x to the power 1 and we divide it by x to the power 1, we get x to the power 1 minus 1, which is x to the power 0. And what's anything to the power 0? Okay, gotcha, you got it figured out. Well, in any case, what is anything to the power 0? Let's see if people remember. Yeah, it's going to be 1. Okay, so that's why we can cancel those two x's. Okay, it's kind of the same thing happening with all these other terms where we just consider x plus 2 to the power 1 divided by x plus 2 to the power 1, that's going to again be equal to x plus 2 to the power 1 minus 1, which is just 0, and that's equal to 1, which is why those two terms just go away. It's like multiplying the entire rational expression by 1. Okay, so got that cleared up. Let's try this other one here. It looks harder. We've got 3x squared plus 11x minus 4 divided by 8x cubed minus 40x squared divided by 3x plus 12 over 4x to the 4th minus 20x cubed. Now let me ask the class, how should I proceed? What's the first thing I should do? That's right, we can multiply by the reciprocal, or we need to flip the second one, right? Okay, remember, I do want you guys to remember, where did I write that? What the thing that we need to flip is the divisor, okay? That's the second expression here, okay? We need to flip the divisor. Okay, so one of them should stay the same and one of them should get flipped, and the one we need to flip is going to be the one on the right-hand side. Okay, if we flip the one on the left-hand side, it's like doing the right-hand side divided by the left-hand side. Okay, so we need to remember that that's the one we flip. So let's do it. We get, you know what, I can be smarter than this. Watch this. Huh. Okay, so we can divide that by 4x to the 4th power minus 20x cubed. Not divide, multiply. So we change our sign to a multiplication sign and we flip the expression on the right-hand side, the divisor, and we're going to divide by 3x plus 12. Okay. So now we've just got a standard multiplication problem, and what we do now is just either multiply straight across, then factor, or factor, then multiply straight across. I like factoring first because it makes everything nice and clear, so we're going to do that. So let's try this first one. We want to factor the first term here. So let's have a little bit of room for some scratch work. If we've got 3x squared plus 11x minus 4, we want something which multiplies. We want two numbers which multiply to 12 and sum to 11. Multiply to negative 12 and sum to 11. So I think we want the numbers. Let's see, what should the numbers be? Let me ask the class. You want two numbers that multiply to negative 12 but sum to positive 11. 12 and 1 is really close. Yeah, 12 and negative 1, that's where we want to be. Yeah, we want to use 12 and negative 1 here. Okay. So let's see here. We want to split up this middle term here as 3x squared, and we're going to write plus 12x and minus 1x minus 4. And now we want to do the grouping game. Okay, so the grouping game means take a GCF out of each of these guys. So we put parentheses around each of these and a plus in the middle, and we take out a GCF out of each so that we get the same factor inside. So on this one, I'm going to take out 3x. We'll have x plus 4. And on the other one, I'm going to take out a negative 1, and then we'll have x plus 4 inside. And now what I'm going to do is combine the 3x and the minus 1 into a single term. I'm going to anti-distribute we'll have 3x minus 1, and we'll multiply that by x plus 4. Okay. Is everyone still with me? Should I go back and go through that one more time? Okay, seems like everyone's good for the time being. So I'm going to go ahead and insert that information into my thing here. I'm going to write 3x minus 1 and x plus 4. That's how we factored the top of the first one. And I'm going to erase my scratch work down here so I have more room to do more scratch work. Okay, now I need to factor the bottom. It looks like I can take out a factor of the GCF. What should the GCF be that I can take out of the denominator here? What's the GCF that I can take out of there? Yep, Morgan's got it. Shrudi's got it. Abdul Rahman also got it. We can take out 8x squared from each of these two terms. So we can take out 8x squared. And left inside, we've got x minus 5. Yeah. All right. And I'll do the next two just for speed's sake. 4x to the fourth minus 20x cubed. We can take out a GCF of 4x squared. No, 4x cubed. Excuse me. 4x cubed, and we'll be left with just x minus 5. And our denominator is going to just be, well, 3x plus 3 times x plus 4. I guess we can take a greatest common factor of 3 out of there. Okay, so then we just multiply straight across. We get 3x minus 1 times x plus 4 times x minus 5, and we'll put the 4x cubed out front. It will divide that by 8x squared times x minus 5 times x plus 4. And now we begin the cancel game. We cancel x plus 4, we cancel x minus 5, and we cancel 4 and 8. We take a power of 4 out of each of those. We're left with a 2 on the bottom, and we take two powers of x out of the bottom and the top, making the top power 1. And we're left with x times 3x minus 1 divided by 2, just 2. Okay. So how are we feeling about that problem? Does that feel okay? Is there any part of that that I could go back and explain a little bit better or in more detail? Why wouldn't we implement the 3 in the denominator? Let's see, implement the 3 in the denominator. Thank you. I missed the 3, that's why. Okay, mistake I made here. I forgot to multiply this 3 here. So this should have also had, this 8 here should have been not an 8, but a 24. In any case, 4 still goes in. And instead of 2, we would have had 24 divided by 4 is 6. Yeah, okay. Thank you, Morgan and Marissa. You guys both saved my butt. Yeah, you guys will find I make a lot of mistakes like that in class. I don't know. part of it's just like my brain is just focused on like communicating, and so minor arithmetic, sometimes I mess it up. So thank you for catching that. Please do let me know if I ever make a mistake on the board. I think the rest of it is all right, though. Yeah. Okay. Well, it doesn't seem like there's any other questions there, so we'll move on to adding and subtracting rational expressions. Okay. So essentially, anytime that we want to add or subtract rational expressions, we need a common denominator, okay? We're going to first talk about how to add them when we have a common denominator, and then after that, we're going to figure out how to get a common denominator in the case when we don't have one, okay? So if we have one, we just add numerators. In other words, combine like terms. So, for example, we could have x squared over x minus 3 plus 2x squared minus x plus 1 divided by x minus 3. Okay, and all we want to do here is, since we have a common denominator of x minus 3, we just want to add the numerators, okay? It's not unlike adding and subtracting fractions, right? If we want to do 4/5 plus 3/5, we just get 7/5, right? We just add the numerators when we have a common denominator. We're going to do the same thing with rational expressions. So we're going to keep our common denominator of x minus 3. We're going to take x squared plus 2x squared. It'll be 3x squared minus x plus 1. And that'll be how we add those two expressions, okay? If it's a minus sign, same deal. The only thing we have to be careful about is we need to distribute the minus sign onto each of the terms in the polynomial in the numerator on the right-hand side. So we need to subtract each of those terms if we're subtracting. Okay, so let's try this one on our own. I'll give you guys 1 minute. You can try that one on your own. All right, would anybody like a little bit more time to try this one on your own? If so, please raise your hand and we'll take another minute or so. All right, people feel okay? All right, so what do we think here for our numerator? What should we have on x minus 6 plus x plus 8, all divided by x plus 1 squared? Oh, uh-oh. There we go. Okay, yeah, 2x plus 2. I think that's right on the money. We should have 2x plus 2. And we're going to divide by x plus 1 squared. Okay, I'm not sure if my Teams is glitching right now or not, but I'm going to proceed. Can everybody still hear me? Yes, okay, great, thank you. All right, I'm just paranoid now that Teams is going to crash on me again. All right. Yep, we should just keep the denominator and just add the terms in the top, and that's what we get. Okay, maybe that was too easy for you guys. Let's try doing things without a common denominator. Okay, without a common denominator, the process is find one, then add, as previously described. Finding one is typically done through finding the LCM or LCD. What is it? I think it's LCM. Let's see. No, it's the LCD. I always get those mixed up. Okay, LCD, least common denominator. Okay. And what is the least common denominator? It is the simplest expression which has both denominators as a factor. Okay, so let's have an example. What is the example that I want to do? I want to do this one, I think. 2x over x plus 1. And we want to subtract from that x over x plus 2. Okay, we don't have a common denominator here. Okay, so in a similar fashion to finding a common denominator for just adding and subtracting regular fractions, what we're going to do is we're going to multiply each of these by 1 in a special way. I'm going to multiply the right-hand side times x plus 1 divided by x plus 1, right? I haven't changed it at all. I'm just multiplying by 1. And on the left-hand side, I'm going to multiply by this denominator, x plus 2 divided by x plus 2. And what are we going to get? On the left-hand side, we'll have 2x squared plus 4x divided by x plus 2 and x plus 1 minus x squared plus x divided by x plus 2 times x plus 1. Now we proceed as previous. We have a common denominator here. So all we have to do is subtract straight across. Okay, I have to be careful though. I need to remember that I should subtract each of these two terms, okay? So really this is going to become 2x squared plus 4x minus x squared minus x divided by x plus 2 times x plus 1. And that will be equal to 2. I'm going to need another page. I might need another page here. That'll be equal to 2x squared plus 4x. No, sorry, plus 3x. Oh, what am I doing? Not 2x squared either. Sorry, we should subtract x squared from 2x squared, and we'll get x squared. And then we should subtract x from 4x. We get minus plus 3x. My brain just turned off for a second there. Okay, so that's how we would simplify that one. Okay. So we sometimes will have a bit more complicated of a situation. So let me add a page and talk about how to find the LCM when things are a bit more complicated. This will be example 2. Okay, so what if we have something like x plus 1 divided by 2x squared times x minus 2 times x minus 3. And we want to add 2x divided by x times x minus 3 times x plus 4. Okay, so now what we want to do is find the least common denominator for these two denominators. However, one thing that we could do is, yes, we could just take the entire denominator here and replicate it on the right-hand side, multiply by that divided by itself, and multiply the whole thing by 1, and then do the same thing with this other denominator. We could do the same thing that we did before. However, it's a little bit crude, and it's more work than we need to do, okay? Because we can instead find the least common divisor, or the least common denominator between these two is going to be the smallest expression which contains each of these as a factor. But some of these expressions are common in both denominators, okay? We have 1 power of x in each denominator, and we have 1 x minus 3 in each denominator. So what we're going to do instead is we're going to multiply each of these expressions by 1, but we're only going to include the expressions which are missing in that denominator from the other denominator. So on the first one, we want to multiply by something divided by something, and what should go on the top and bottom there should be whatever is on the denominator on the right-hand side, which is not present in our left-hand side denominator. So I'm going to look for things which we don't have. Well, I have an x minus 3. I don't have an x plus 4, so I'm going to include that here. Okay, now we want to do the same thing on the right-hand side. We want to find the pieces which are missing from the right-hand side that are present on the left-hand side. And it looks like I'm missing an x minus 2, a 2, and 1 power of x, because I only have x on the right-hand side and not x squared. So on this side, I'm going to multiply by what's missing. What's missing is a 2, 1 power of x, and x minus 2. And then we put the same thing on the bottom. Okay, so now our entire thing becomes, well, x squared plus 4x plus x plus 4 divided by 2x squared times x minus 2 times x minus 3 times x plus 4, and then plus 4x squared times x minus 2 divided by 2x squared times x minus 2 times x minus 3 times x plus 4. And now both of these two denominators are the same. Okay, that was the whole game that I played, was to make those denominators the same. So now all I have to do is add straight across. So let's simplify a little bit. We'll have 2x squared times x minus 2 times x minus 3 times x plus 4. That'll be our denominator. And then our numerator will be x squared plus 5x plus 4 plus 4x cubed minus 8x squared equals same denominator, 4x cubed minus 7x squared plus 5x minus 4 plus 4. Okay, so that's how we would take that one all the way. Any questions about how we did this addition where we did not have a common denominator and we used the least common denominator to find these expressions, which we should multiply each side by, talking about the green and the pink expressions. Is any of that confusing? Okay. Seems like things are okay. All right. Do I want to? Yeah, I want to move on. This might be a good one for you guys to try. Oh, well, shoot, you don't have the notes, do you? I can. Do people want me to upload these notes as a PDF to the Blackboard? That might be helpful for you all. How about it? Anybody for it? Yes, yeah, with lots of exclamation points. Okay, yeah, okay, then I'll upload these to Blackboard as a PDF so that you can try, because this one might be a good one. Maybe I'll designate a highlighter color. The purple highlight color would be good ones for you to practice on your own. Okay. We're going to move on to this more complicated example. Okay. So this looks kind of wacky, but let's just see if we can use our basic principles to get us through it. Okay. So first of all, the numerator, we've already got a sum of fractions. So let's just try to take care of that first. That seems like the easiest thing to do is probably going to be to combine those two into a single fraction. And then we would have a fraction divided by a fraction, and we would know how to do that. So let's first combine those two. Well, we consider what's missing from the denominator on each of these two terms. Well, this first term does not have an x in the denominator. So we're going to multiply by x over x. And the second term, 1 over x, does not have a 2 in the denominator. So we're going to multiply by 2 over 2. And we'll get x over 2x plus 2 over 2x divided by x squared minus 4 over 2x. And now we can simplify the numerator into just x plus 2 over 2x divided by x squared minus 4 over 2x. Now, who can help me tell me how I should proceed from here? You're on the right track, Morgan. We can get rid of the 2x, and you could probably get away with just immediately getting rid of that. for the sake of showing our work as completely as possible, I am going to choose the flip method first, and then we'll cancel the 2x. But very good. Multiply by the reciprocal of the bottom. That's right. We're going to change this. We're going to write x plus 2 over 2x. We don't like dividing by fractions. Let's multiply by the reciprocal of that fraction. 2x over x squared minus 4. And then we're going to cancel these 2x's. And then we'll just be left with x plus 2 over x squared minus 4. Now, Morgan was way ahead of all of us. Her thought was initially just, why don't we just cancel the 2x immediately and we'll be left with x plus 2 over x squared minus 4. That's absolutely the right thinking. The way that we taught how to simplify it was using this flipping thing, but if you want to do it that way, as long as you do it right, that's totally fine and great and wonderful. But this is how I want to write it, just for the sake of taking notes. Multiply 2x to 1/2 plus 1x. Yeah, I see what you mean. Yeah, we could have multiplied across before canceling these, but that's going to get us to the same place. For example, we would wind up with 2x times x plus 2, and then on the bottom, 2x times x squared minus 4, and then you can cancel 2x with 2x. If you want to do it that way, that's also fine. Okay. Any questions about, could you simplify even further and factor the bottom? Aha, you're absolutely right, we could. We can take this even further. Thank you for pointing that out. We can factor the bottom. The bottom is a difference of squares. We know we can factor a difference of squares as x plus the square root of the right-hand side and x minus the square root of the right-hand side. Very good, catching things that I didn't even see. Fantastic. We can take that all the way to 1 over x minus 2. Okay. Thank you very much, Connor. Okay, any other questions about how we did this kind of more complicated problem? All right, now one thing I will note is that the order doesn't necessarily matter so much. If you could have taken a different route here, you would have gone, maybe somebody could have tried to do 1/2 over x squared minus 4 over 2x, and then add that to 1 over x squared minus 4 over 2x. You could have done this method instead. But you're going to get to the same place and you might have to do more work. In fact, you probably will have to do more work. So I think we found the fastest way to get to the end with the red route. Okay, on homework and assessments, will we need to simplify that much? Yeah, if I were to give you this question on a homework or on an exam, and you took it to here, I probably would take off a point for not taking it all the way. So shame on me for not recognizing that we can go all the way. So this would get something like, I don't know, 9 out of 10 points. And this would be like 10 out of 10 points. Yep, no problem. Okay, so it's 9:30, we have 15 minutes. At least I think we have 15 minutes. It's Thursday, today's a long day. Okay. We could do this activity and then we'd be 1 day behind, or I can continue to do the next section, in which case we'd be like half a day behind. Maybe I should just commit. All right, we're going to commit to being 1 day behind for the time being, and we're going to do this activity here. Okay, so here's what I'd like to do. We're going to have hang on. Use it for the whole semester. What's the average cost? No, we're not going to do that activity. I changed my mind. I don't like that activity. We're going to move on. Okay. So what are we going to talk about now? We're going to talk about rational exponents. Okay, so first of all, let me remind you what a rational number is. It's a ratio of integers. In other words, a fraction. Some examples of rational numbers. 1/2, 3/4, -1/600. Also, 0, 3, whole numbers, right? Because we can write those as 3 divided by 1 or 0 divided by 10, right? They are a ratio of integers, etc. But not numbers like pi or e. Okay, numbers like pi and e are not rational numbers. Okay, but we want to talk about how to compute things like x to the 1/a. So let me move that and we'll have the motivating question. Motivating question. What is x to the power 1/a? Well, we can explain what this means by using one of the rules that we already have. Okay, for example, x to the 1/a, if we were to take this to the 8th power, how would we handle those exponents? What would we do with those exponents to write them as a single exponent? What should I do with them? Should I add them? That's right, we should multiply instead, right? We should take a times 1/a. Well, that would be a/a, which would be 1. And x to the power 1 is just x. So we have a number here. We have a number, x to the 1/a. And it's the number such that if we take it to the 8th power, we get x. Can someone tell me what I'm describing right now? Okay, haven't quite made the connection yet, it seems like. What if I said the following? What number should x be if x squared equals 4? Yeah, we should have 2. And what's the relationship between the number 2 and the number 4? That's right. 2 is the square root of 4. So if we have some number, what number should x be if x to the power a equals 4? Then x is going to be equal to the a-th root of 4. Okay, that's what we're describing here. Okay, so when we have a rational exponent, okay, when we have a rational exponent, what we are really talking about here is roots, okay? Either square roots or cube roots or 10th roots or nth roots is sometimes how we call them. We call them nth roots because we consider the n to be any integer, okay? So that's how we use these rational exponents, okay? Let's see, there's one more thing that I want to talk about, which is how to compute something like this. How do we compute something like 8 to the power 2/3? Why don't we start with 8 to the 1/3? Well, 8 to the 1/3 we know is going to be the cube root of 8. And the cube root of 8 is some number such that if I take that number times itself 3 times, I get 8. That's going to be the number 2. Okay, 2 times 2 times 2 would be 8. But some confusion can set in with people when we try to do something like 8 to the 2/3 power. Okay, and the way we want to handle something like this is to rewrite it. Okay, we want to rewrite it in a more friendly way. Okay, and so I'm going to actually write 8 to the 2/3 power as being equal to 8 to the 1/3 power, where 1/3 is being multiplied by 2 in the power. And I know that if I have powers being multiplied, it looks like the result of what would happen if I took 8 to the 1/3 and then squared it. Okay, if I were to move from here to here, then I've done just what the rule says. If I take a power to a power, then I multiply them, right? So I'm going to rewrite 8 to the 2/3 power as 8 to the 1/3 squared. And now I know how to do this because I know 8 to the 1/3 is going to be equal to 2. And then all I have to do is square it. And I'm left with 4. Okay, so that's how I deal with a rational exponent where the numerator of the rational number is not 1. Okay, that's what that is supposed to illustrate. Okay. There's a couple more properties that I want to talk about. These are specifically properties of the square root. And there's let's see here. Any real number x square root of x squared is equal to x, so value of x and x squared. Square root of x squared. Okay. So this is just kind of the definition of the square root. Square root of x squared is equal to the absolute value of x for any given value x. So if we take some value x, We then square it, and then we take its square root. We get the absolute value of x. And this works for negative values of x as well, because if x is a negative value and we square it, then x squared will be positive. And if we take the square root, then we get x. Okay, so that's the definition. We also have that the square root of x, if we take that and we square it, we get x. That's sort of the definition. Now 2. If x squared equals to a, then x is equal to plus or minus square root of a. Okay, so this is one thing that a lot of students tend to forget. We can also have a negative number, right? For example, 3 times 3 is equal to 9, but negative 3 times negative 3 is also equal to 9. So if we want to talk about the square root of 9, we're talking about plus or minus 3. Okay, so that's one rule there. And lastly, the important ones that I wanted to talk about, square root of a times b is equal to the square root of a times the square root of b. And the square root of a divided by b is equal to the square root of a divided by the square root of b. Okay, and that just comes from the old rules about exponents, right? The old rules were that if we had a times b to the power p, we would make that a to the p times b to the p, and so on and so forth. So a square root is really a 1/2 power. So the same rules are going to apply to multiplying things under the square root and dividing things under the square root. We're going to distribute that 1/2 power. Okay, so let's try some of these examples here. We're asked to simplify these. Okay, so let's just start with this first one here. Okay, so this one's not really anything new. We're just going to use the rules that we had for powers before. Okay, we're just going to use the rules for powers that we had before. If we have 2x to the 1/3, that's a power, times 5x to the 1/4, that's a power. All we're going to do is multiply 2 and 5. So we get 10. And now I should multiply x to the 1/3 times x to the 1/4. One second. Okay, that's my alarm that I'm out of time. But let me finish this last example here. What we should do with these two is we have two different powers of x being multiplied. What we need to do with the powers is add them. So this should become 10x to the 1/3 plus 1/4. If we want to add those, we should get a common denominator. It should be 10x to the 4/12 plus 3/12 equals 10x to the 7/12. All right, and that's how we can simplify that. All right, we'll pick up here next time, which will be on Tuesday. Don't forget, we don't have class tomorrow or on Monday because of Martin Luther King Day. So have a great weekend. I'll post the homework and I will send an email notifying you when the homework is due. Let me put upload notes on my to-do list here. I'll upload them to Blackboard and I'll include in the email the location of them, but they should be on somewhere on course content. All right. Well, have a good weekend, rest up, and yeah, enjoy yourselves. Yep, see you on Tuesday. My pleasure.